geology students. Here's a topographic map. We're going to start working on topographic maps. I'm making this short video to help you with your topographic maps lab that's coming up on uh, today, and it'll be due tomorrow by 5 p.m. Topographic maps show you elevation above sea level. They also show you features like hills, valleys, ridges, and depressions. Um, and these lines that you see on the map, ignore the fact that these are red, by the way. He's trying to make a point here. Usually they're not in red, they're black or brown. But um, what topographic maps show you is elevation above sea level. How high above sea level are you at a certain point? And they're used for many things, land planning uses, real estate, investments by the military. And here you can see a whole bunch of lines, and then these lines with these are called hatchers, Hachures. So you see mostly solid lines, but hatchered lines as well. You see a creek or a river in blue here. First thing you want to note always on all of these maps is north is always up, east is to the right, west is to the left, and south is down. So this way, from here to here would be northeast, northwest, southeast, southwest. In the United States, we these numbers are in feet. In the rest of the world, they'll be in meters. We're mostly going to be working with U.S. maps, but you always want to know ahead of time, is it in feet or meters? If it's a U.S. map, it's usually in feet. So, if you're standing right here at this point, you're 250 feet above sea level. If you're standing right here, you're 260 feet above sea level. If you're standing right here, you'll be at 270 feet above sea level. So, notice that for this map, the difference in elevation between adjacent lines is 10 feet. You go from in tens, 250, 260, 270. So we say that the contour interval for this map is 10 feet. The contour interval for this map is 10 feet. We also see that different features here. And watch the other videos, but here you can see as you go up here, you're walking uphill, 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 and then you get to the top of this. When you see a bullseye pattern and you're walking uphill like this is a hill. This is a hill. I used to be in the Army, and we always wanted to locate our artillery on the hill so we could see the enemy downhill. Anyway, here you see another bullseye pattern with these hatchered lines. And notice as you walk from here down to here, down to here, you're walking downhill. This is a depression, a hole in the ground. Now, here you see a bunch of U's. You see a bunch of U's here and a bunch of U's here and U's here, and there'd be another one right off the map here. Well, when you see U's like this, and they're pointing to the higher elevations, notice this U is at 250, this is 260, the U is pointing to higher elevations. That means you're looking at a valley. So this is a valley, and this is a valley. And this must be a valley too, because a river is flowing through it, and rivers only flow through valleys. Rivers flow downhill. So another way of saying it is, for a valley, the contour lines will U or V, sometimes they're V-shaped, but they'll point upstream. So this creek is flowing to the southwest. In between a valley is always a ridge. So this would be a ridge. So think of it like this. A valley, water is going to flow through a valley, right? going to flow through a valley. But on both sides of a valley, you're going to have a ridge, high ground. And then on the other side of a ridge, so you got ridges on both sides of valleys. And you might have another valley over here. Oh, it's hard to show this. I can't do it with the paper. Let me show it. Let me show you by going to Google. So here's the topo map, and so this is 1,000 feet here. You see 700 feet over here. So this way, going to the southwest must be uphill. So this V is pointing upstream. So this must be a valley, and there's a ridge, which are these U's on both sides of the valley. Look at your lab manual as well. That's going to help you. On the bottom of the map, there's always a scale. So for this map, let's just say for this map, the scale is 1 to 20,000. What does that mean when you see on the bottom of a map it says 1 to 20,000? What that means, ladies and gentlemen, is that 1 unit of distance on that map is equal to 20,000 of those same units of distance in the real world. Another way of saying that is that if I were to walk 1 inch on this map, from here to here, about an inch, I would have walked 20,000 inches in the real world. Or if I were to go 1 foot on this map, then I walked 20,000 feet in the real world. If I walked 1 centimeter on this map, I walked 20,000 centimeters in the real world. Okay? So that's what scale means. It could be any unit of length. 1 is equal to 20,000 of those same units of length in the real world. Now, if the map is a scale of 1 to 100,000, then it's going to cover more ground. It's 1 inch on that map would be 100,000 inches in the real world if it was 1 to 100,000. The closer the lines are together, the steeper the ground is. So if I were to walk up this hill, it would be a lot easier to walk this way than to walk this way because the lines are closer together. How high above sea level would I be right here? Well, I'm right between 250 and 260, so I would be 255 feet above sea level right here. As I walk towards the northwest, I'm walking uphill to 260 feet, 265, 270. See this X on top of the hill? How high above sea level am I on the top of the hill? Well, in order to figure that out, I take the nearest line from the X, which is 290 feet, and I add, I'm going to write that down. I'm going to calculate that for you. And you can do this as well. It's easy. 290 feet plus 1/2 of a contour interval. What's the contour interval for this map? 10 feet. So your answer would be 290 feet plus 1/2 of 10 feet. Your answer, therefore, would be 295 feet. So at the top of this hill, at that X, I'm 290 feet above sea level. We're going to be making contour maps, so always remember, when contour lines cross creeks, they point upstream. They point to higher elevations. This 250 line points to the 260 line over here. Okay. Don't forget, when you see these hatchered lines, these lines here, those are it's for a hole in the ground, a depression. See that? If that's the 1,000-foot line, and this is a 1,200-foot line, the first hatchered line is equal to the nearest solid line. So it doesn't go from 1,000 to it doesn't start to go first. It goes up, and then it goes to that first hatcher line must be equal to the nearest solid line. Then it starts to go down. Okay. Now we're going to learn to make topo maps, and I want to show you. I drew a little picture here for you. Let's say you had a map like this, and you have these elevations: 72 foot above sea level, 81 foot, 87 feet, 83 feet, 90, 95, 100, 104, 101. You have all of these elevations that some surveyor took, and they're represented by these blue dots. Now let's say you wanted to make a contour map or a topographic map for this with a 10-foot contour interval. This is the way you would do it, ladies and gentlemen. Okay, here's a 72 foot, here's 81 feet, right? Where would 80 fall, right? I'm going to put it in a different color here. Where would 80 fall between these 2 points? Well, it would be closer to right about here, right? 77 and 87, those 2 points. Where would 80 fall? Right about here, right? 72 and 83, 2 points. Where would 80 fall? Right about here. Okay, now we can go ahead and make our 80-foot contour line by joining these 2 points, and it should never be jagged. Remember, the V's upstream because this is a creek, and this is upstream. This is at higher elevation over here towards the northeast. So then you would go like, and it's not going to go between these 2 points, because that's 72 and 77. It's going to be between these two, 77, 83. 80 would be right in the middle. So the line would go like this. Oh gosh, it's hard to draw like this, but let me try to make it neater for you. 80's right here. So 77, 83, 80 would be right about here. And then you always want to put the number in here so that people know what that line represents. And put a little V so it points upstream. Okay, that's your first line. Now let's contour interval of 10 feet. So the next line should be 90 feet, right? 80, then 90. So 83 and 91, where would 90 fall? Right about here. I'll put in the same color here. Okay, let's do the 90. 90 would be right about here. It's closer to the 91 than the 83, right? Oh, we got a 90 right here on the dot. That gives us a nice point. It won't fall between here, but that's 95 and 101. 90 would fall right about here, right? 81 and 95, 90 would fall right about here. So we can go ahead and try and make nice smooth points. Make sure it points upstream. And this is our 90-foot line. Well, we could do a 100-foot line too, because right here we got 100. Right here's 104 and 90, so 100 would be right about here. 95 and 101. So 100 would be right about here. So we can go ahead and put the 100-foot line in here. And it's somewhere off the map because we don't see any hundreds over here. So we'll just go up off the map. So that's our contour map for that bunch of points. Now you're going to make 3 different contour maps, and in your lab there's 3 videos to watch that will help you do that. If you have any questions, let me know. But watch those 3 videos and watch this one, and then that'll help you do this lab. I'll talk to you later.